learners, welcome back to my channel Maths Made Easy with AB. So this is a continuation of our series on functions and calculus, introduction to the concepts, learning the concepts of functions and calculus. In the earlier video we had seen functions basically and drawing, sketching functions, what are functions. Today in this lecture we will be studying specifically only about odd and even function. We will be solving few of the numericals and few of the important concepts that are needed while defining odd and even functions. So now let us understand. In the earlier video you already saw that y is equal to fx denotes a function. Y is equal to fx denotes a function. Say for example it is denoted by x square. So this is a function, right? So what is an even function? Let us first see what is an even function. Yeah, what is an even function? So what is an even function? So basically if f of minus x will be equal to fx, then this is called a even function. If f of minus x will be equal to fx, then it is known as a even function. Yeah, very simple. I'll show you with the help of an example. First, let me define both of the functions. What is odd function? Just the opposite. What is odd function? If f of minus x, if f of minus x is equal to minus fx is equal to minus fx, then y is equal to fx is known as odd function. If f is equal to minus x is equal to minus fx, then y is equal to fx is odd. Remember, if f of minus x is equal to fx, for a function y is equal to fx. This is the definition for a function y is equal to fx. Yeah, let's remove y is equal to x square. This was an example that I took. So for a function y is equal to fx, if f of minus x is equal to fx, then this is known as even function. If f of minus x is equal to minus fx, then this is odd function. Let us see an example. So I am taking a function y is equal to x square. Y is equal to x square is equal to fx. So now f of minus x. If fx is equal to x square, what will be f of minus x? Simply you have to replace x with minus x whole square. So minus x whole square will be x square. So here this is same as y is equal to fx, right? So f of minus x is equal to fx. Therefore the function y is equal to fx is equal to x square is what? Is an even function. Is an even function. I think this is very much clear, right? So now the next example, let us understand with the help of next example. I am starting this chapter with very much easy concepts. So somebody who has no idea about odd and even function can watch this video, and I will be eventually building up tough concepts that will be required for JEE Mains and JEE Advanced examination. So this video will contain entire odd and even function. So if you watch the video till the end, I just guarantee you that any problems that comes in entrance examination, in any entrance examination, you can be easily able to solve that problem. Yeah. So y is equal to fx. Say for example, a question is y is equal to fx is equal to x cube. So what kind of function is this? Is it odd or is it even function? So what I will do first, I will simply put f of minus x is equal to, so this will be minus x, x will be replaced by minus x whole cube. So this is minus x cube. So minus x cube is what? Minus fx. So f of minus x, here what you are getting? F of minus x is equal to minus fx. Therefore the function y is equal to fx is equal to x cube is odd function. Is odd function. I think this much is very clear to you all. So this was the basic definition and a basic example of odd and even functions. Guys, let me also tell you one important concept here. Say for example, the question is y is equal to x cube minus 1. Y is equal to x cube minus 1. Yeah. So what kind of function is this? This is fx. This is fx. So what you will do first, you will find f of minus x. Yeah, you will find f of minus x. So f of minus x will be minus x whole cube minus 1. So this is minus x cube minus 1. This is minus x cube minus 1. If I take minus common, x cube plus 1. So is this minus fx? So am I able to write this in the form of f of minus x is equal to fx? This is not fx, and this is definitely not minus fx. Therefore, the function y is equal to x cube minus 1, y is equal to x cube minus 1 is equal to fx is neither even nor odd. So you have to keep that in mind, that a function need not be odd or even. A function can neither be odd nor even. This can also happen. So a function can be odd, a function can be even, or there can be case where a function is neither odd nor even. I think this much is very clear to you all. Yeah, the basic definition. Now always I take graphical approach. If you have not seen my series, play with graph, I will recommend that you first watch that series, because this topic helps you to solve problems related to calculus. Not only calculus, you also study physics. So mechanics, let me tell you, if you are not strong in function, graph, mechanics will create difficulty as you move on till rotational mechanics. Yeah, so you must study this chapter very, very thoroughly, and I recommend you to watch all my series regarding functions and play with graph. Yeah, so let me now move on to the next part. Say for example, the graphical significance of odd and even function. We will see the graphical significance of odd and even function. So let me draw the graph of y is equal to x square. In my series, how to draw a graph, how to draw parabola, we have already seen that this is the equation of a parabola. So a parabola equation is basically ax square plus bx plus c. If a is positive, I'm just repeating it in case you have not seen the video. In the description you will find the series links and you can go and see. So if a is greater than 0, then this becomes an upward opening parabola. If a is negative, it becomes a downward opening parabola. So here a is 1, right? B is 0, C is 0. So basically the origin over here of the parabola is what? The origin is the vertex of the parabola. So this becomes the parabola in this case. This is the y-axis, this is the x-axis. So I'm omitting this part because this is a repeat of what we have already seen in other videos. So this is the graph of y is equal to x square. Let me tell you, y is equal to x square, we just saw that y is equal to x square is a even function, right? Y is equal to x square is an even function, which means f of minus x is equal to fx. Now, even functions are always symmetrical about the y-axis. You can see this is the y-axis. Is this part symmetrical with this part? Yes. So remember, even functions are symmetrical. Guys, just write it down in your notes that you are taking. Are symmetrical about y-axis. These are symmetrical about the y-axis. So if you know the graph of this side, you can draw the graph of this side. Means y part positive y and positive x, and this is negative x. Yeah, so this side it is symmetrical about y-axis, guys. This is the y-axis. So this basically acts as a mirror. Yeah. So this is symmetrical about y-axis. This is even function. Let me take some more examples of graphs which will be symmetrical and which will be even function. Say for example, if somebody has given you y is equal to mod x. Yeah, this is fx. Y is equal to mod x. This is fx. Yeah, so let me now erase this part. Write it down here. Y is equal to fx is equal to mod x. Yeah, so you know the graph y is equal to mod x. How is it, guys? I have already taught you in the modulus series. It consists of 6 videos, and I hope you all must have seen that video. This is x-axis, this is y-axis, and this is the graph of y is equal to mod x. Students, this graph y is equal to mod x is symmetrical about y-axis? Yes, this graph is symmetrical about y-axis, which means this is even function. Very clear to you all? Also you can see, just I am deducing that y is equal to fx is equal to mod x, right? F of minus x, guys. What will be f of minus x? Mod of minus x. Mod does what to any function? It makes it positive. If mod x is equal to fx. So f of minus x, the value is equal to fx. Hence, This is even function. Also from the graph you can see it is symmetrical about y-axis. Now let us see the next problem. Let us now see the next problem. So we already saw the graph of y is equal to mod x. Now let us see the graph of y is equal to cos x, guys. Y is equal to cos x. If you see play with graphs, in the 4th or 5th video, I don't remember, in the 4th video maybe, you will see how to draw trigonometric functions. There you have already seen the graph of y is equal to cos x. So this is x-axis, y-axis. Cos x always lies in between +1 and -1. And the same is for sin x also. Yeah, we have already seen in that video. And guys, this is the graph of y is equal to cos x. Yeah, this value is pi by 2. This value is pi. This value is minus pi by 2. And this value is minus pi. So this is the graph of y is equal to cos x. Guys, just see. This graph is also symmetrical about x-axis. No, this part is like this and this part is like this. So this is symmetrical about y-axis. Sorry, this is symmetrical about y-axis. So y is equal to cos x is also even function. Y is equal to cos x is also even function, and you already know, guys, that y is equal to f(x) is equal to cos x. If I find f of minus x, so this is cos of minus x, which is cos x, you must have learned this, which is equal to fx. So f of minus x is equal to fx, hence y is equal to cos x is also an even function. Yeah, I think till now this is very clear to you all. Let me take some example of odd functions. Now let us understand what is the graphical significance of odd function. Yeah. So at first I'll take the graph of y is equal to x cube. Y is equal to x cube. So y is equal to x cube. The graph is somewhat like this. Y is equal to x cube. This is x axis. This is y axis. This is the graph of y is equal to x cube. So remember, this is odd function. We already saw few minutes back. So y is equal to x cube. If you see, remember that odd functions, the graph is symmetrical about what? Can you see, students? Can you guess? It is symmetrical about the origin. It means about this point it is symmetrical. So odd functions are symmetrical about the origin. So if you know the graph of this side, you can draw the graph of this side. Very important, just keep note of this. Odd functions are symmetrical about the origin. So students, you can see now how we are building up, how we are eventually building up on the basics. We saw some basic problems and now we are building up on that using graph. Yeah. So it is symmetrical about the origin. So this was the first graph that we saw. Let us now see the graph of y is equal to sin x. Y is equal to sin x. You know the graph of y is equal to sin x, already seen in play with graphs. Trigonometric function. This is +1. This is smaller. This has become very small. So let me just erase this part out. This is -1. So y is equal to sin x. It lies in between +1 and -1, and you have already seen the graph. It is like this. This part is pi, this part is minus pi. Here in between you have minus pi by 2 where the value is 1, and here it is minus pi by 2. Yeah. Now you can clearly see that this graph is symmetrical about the origin. This graph is symmetrical about the origin, which means y is equal to sin x is an odd function. Also, if you see, if this is equal to fx, what will be f of minus x, students? Sin of minus x is minus sin x, right? So this shows that y is equal to sin x is an odd function. Graphically, it is symmetrical about the origin. So this was example of sin x. Similarly, for tan x, we have seen the graph. So tan x graph, if you all remember, so y is equal to tan x graph, if you all remember. So the tan x graph had something like this. Pi by 2 minus pi by 2, value is not defined at pi by 2, like this. So this is also symmetrical about the origin. So tan x, this is not sin x, this is tan x now. This is now tan x. So tan x is what function, guys? Tan x is odd function. I think this is very much clear to you all now. So if I simply say, you saw y is equal to x square, y is equal to x to the power of 4, y is equal to what? X to the power of 4, x to the power of 6. So y is equal to x to the power of 2n. Y is equal to x to the power of 2n will be what function? Will be even function. And y is equal to x to the power of 2n plus 1. This will be what? Odd function. Even and odd. Got it? This is very clear. If n is 0, if n is 0, if n is 0, let's not take 0, set it for 1. If n is 1, this becomes x square. If n is 1, this becomes x cube, odd function. If n is 2, if n is 1, if n is 1, say for example, this becomes y is equal to x square, this becomes even. This becomes y is equal to x cube, this becomes odd. Right? If n is 2, if n is 2, this becomes what? 4, x to the power of 4, this becomes even. What will this become? Y is equal to x to the power of 5, this becomes what? This becomes odd. Y is equal to x, what graph it will be? Y is equal to x, the graph is like this. Is it symmetrical about what? Origin, right? So that is also an odd function. That is also an odd function. So odd functions are symmetrical about origin, even functions are symmetrical about the y-axis. I think this is very much clear to you all guys. Yeah. So now let us look into the next problem. Similarly, I'll just tell you y is equal to sine x. Y is equal to sine x to the power of, say for example, if I write 2n plus 1. Tell me if it will be odd or even. Tell me it will be odd or even. Yeah, this will be odd. But if I say y is equal to sine, y is equal to sine x to the power of 2n, guys, this will be what? This will be even. And let me tell you, you can take out several deduction from all these 2n plus 1, what will be cos x 2n minus 1. So you already now know how to solve these problems, how to find out whether it is even or odd. If you have any doubts, you can go to the comment section and you can ask them. Now let us take an example to solve a problem. Say for example, fx is equal to 4th root of 1 minus x cube. 1 minus x cube minus 4th root of 1 minus x cube, 4th root of 1 plus x cube. This is the question, and they are asking you whether this function is odd or even. So the question is, find whether the function is odd or even. So for these kind of questions, if somebody has given you a function y is equal to fx is equal to something, yeah, so this is a function of x because it depends on the value of x, the value of y, yeah, so y will be somewhere here. So y depends on x. So odd or even, what you have to do first, you have to simply find out the value of f of minus x. This is the only method of solving these kind of problems, unless you know the graph, yeah, if it is even symmetric about origin or symmetric about y-axis, or not symmetric or not both, then it will be neither odd nor even. So now f of minus x will be 4th root of 1 minus, so this will be minus x whole cube minus 4th root of 1 plus minus x whole cube, guys. So this is 4th root of 1 plus x cube minus 4th root of 1 minus x cube. Very much clear, guys. Simple simplification this is. Now let me take minus outside. What it will be? This will come in front. 4th root of 1 minus x cube minus 4th root of 1 plus x cube. Very clear, guys. This is very simple. Very simply I have solved it. Simplification, just simplification it is. Elementary simplification. Now this part, is this the same? Y is equal to fx? Y is equal to fx? Yeah. So this is y is equal to fx. So f of minus x, the value becomes minus f of x. F of minus x becomes equal to minus fx, which means students, the function that is given over here is odd. The function that is given over here is odd because f of minus x is equal to minus x. So if you get this question, this graph, whatever be the graph, I am not going into the graph right now. So this is not a lecture of graph. So whatever graph it will be, the graph will be symmetrical about the origin. Yeah, I hope this is clear. Now let us take another example. So this was one question. Let us take another example where we have to find out whether the function is odd or even. So the question is, fx is equal to e to the power of x plus e to the power of minus x. Fx is equal to e to the power of x plus e to the power of minus x. Simply what you have to do, f of minus x. So this will become e to the power of minus x plus this will become e to the power of x. Very simple. Guys, this is same as fx. This is same as fx. Therefore, f of minus x is equal to fx. Very simple question. The function this one is even. The function this one is even. I think this much it is clear. Now let us see the next problem. So guys, the next problem is prove that the product of two odd or two even function is an even function. So this is a fact which you must remember. We will go into this proof because it is a very important question that comes in your board examination, and the application is used in solving problems that comes in joint. So basically what they are saying is, if you multiply two odd function, you will get what? Even. And if you multiply two even function, what will you get? You will get even function. So basically this is the proof they are asking for. This is the proof they are asking for. So this is a theorem, or you can say an important deduction which you can use in numerous problems. In this question we will just prove this fact. So you must also keep this in mind. Yeah. So let us now try to prove it. Let us now try to prove this. So let us assume that the two functions, product of two functions, let the two functions be fx and gx. Yeah, let us take fx and gx. And multiplying both you get hx. So hx is equal to fx into gx. Hx is equal to fx into gx, right? So now let me take the first part, product of two odd functions. So if fx and gx are odd, if fx and gx are odd, then what will happen? F of minus x will be equal to minus fx, guys, already taught you. If they are odd, then f of minus x will be equal to minus fx, and g of minus x will be equal to minus gx. I think this is very much clear to you all. Yeah. Therefore, if you see h of minus x, what is h of minus x? Guys, what is h of minus x? H of minus x is, hx is this, so h of minus x is my f of minus x into g of minus x. Hx is equal to fx into gx, so h of minus x is f of minus x into simply replacing x with minus x, x with minus x. Now, since they are odd functions, so f of minus x is equal to what? Minus fx, and g of minus x is equal to what? Minus g of x. Very clear? Minus minus becomes positive, so h of minus x becomes equal to fx into gx. Fx into gx. What is fx into gx, guys? What is fx into gx, guys? It is equal to hx. So h of minus x becomes h of minus x becomes hx. Therefore, what is hx? What is hx? Hx becomes an even function. Hx becomes an even function. So basically this is the proof. Therefore hs is an even function. This becomes the proof of that the product of two odd function is an even function. Product of two odd functions is an even functions. Let us now see the second part. Product of two even function is an even function. Yeah, let us see that part. So now it is not odd. It is what, guys? It is even. Let the two functions be fx and gx. The same thing continues. Hx is equal to fx into gx. Now since they are even, f of minus x will be equal to plus fx, right? And so I am not writing this plus. And g of minus x is equal to plus gx. Clear? H of minus x. What is the value of h of minus x? H of minus x is still f of minus x into g of minus x, because I am simply, this part I am using, yeah. From here to here I am going. So I am simply changing x with minus x. So f of minus x, g of minus x. Now f of minus x, since it is an even function, this minus will go, this minus will go. So I don't need this further step. So simply over here only I am getting fx into gx, which is also equal to what, guys? Which is also equal to what? Which is also equal to hx. Therefore hx is even. Which means this is now clear to you all that the product of two odd function or two even function is an even function. I think this is very clear to you all. Now let us also understand with this, let me also prove I will not prove that point. That's your homework. That's, if you're watching this video, you need to solve it on your own. Do remember that the product of an odd and even function, is an odd function. Similar way you need to solve the question. What I am saying is, I'm removing this part. What I am saying is that the product of an odd and even function, the product of an odd and an even function is an odd function. So this is your homework. You need to solve this part. This is important for your board examination. Yeah. So let me draw a table now. So this was fx, our first function. This was gx, our second function. This was fx, our first, and gx. Now we will see what will happen to addition of this or subtraction of these functions. Fx plus minus gx. This is the third part. Yeah, the fourth will be the multiplication, fx into gx. Clear? And the last column is fx by gx. Fx by gx. Guys, definitely here gx is not equal to 0. Here gx is not equal to 0. Here gx is not equal to 0. So you need to keep this in mind, right? So this is the table. So what I am saying is, say for example, the first function, that is fx, is odd. The second function gx is odd. Guys, O means odd over here. Yeah. So let me fill it with a different color so that you get clarity in this. So if this is odd, this is odd. Odd plus odd or odd minus odd. Odd plus odd or odd minus odd will fetch you an odd function. Clear? Odd into odd, which just saw, it fetches you even function. Odd by odd will fetch you even function. You can prove this, but you need to remember this table, guys. To solve problem, you need to remember this table, guys. Now let us see odd, even. So always remember odd, even. If you add this function, this is neither odd nor even. This is neither odd nor even. Odd even multiplication will give you what? Odd. Yeah. And division will also give you odd. Remember gx, the denominator is not equal to 0, guys. Domain, function, range, we will see in the next video. There it will be clear to you all, right? So this is about odd and even. Clear? Even, odd, same thing. Neither odd nor even. I'm not writing it. And this will be odd. Very clear? This will also be odd. Even plus even, or even minus even will be even. Or let me not write even here, else you all will be confused why I wrote even over here. E. That is E only, even only. Yeah. And what will be multiplication? Even under we saw the proof also. This will be even, guys. This was your homework to prove this is odd. And others also are the homework, you need to solve it on your own. This is even. So even by even, definitely it will be even. Denominator is not equal to 0. So this is the table, guys. Basically this is the table to give you a clear idea when two functions are attached. Two functions, that is fx and gx, they are attached using simple plus minus, divide or multiplication. So what will be the changes that will happen to the function that results? The hx function that we saw with the example, the previously. Hx is equal to fx plus minus gx or hx. So hx will be this. Hx will be even, hx will be odd, neither odd nor even. So this is the table, guys, and you need to remember this table. Now let us solve few examples. Moving to the second example, guys. Yeah. Let us see the next problem. So the next problem is prove that every function y is equal to fx, obviously, can be expressed as a sum of odd and even function. So now the question is, what it is saying is that you get any function y is equal to fx, right? This can be expressed in the form of odd plus even function. So you must keep this in mind, although we will try proving this question, but you must always remember that fx can be expressed as hx plus gx. So if hx is odd, gx has to be even. Yeah, so this is the deduction, but now let us get into the proof of this question. So what, let us take an example. Y is equal to fx is the main function. Yeah, so can I write fx is equal to half, can I write fx is equal to half 2 of fx, 2 cut fx is equal to fx. This is not, guys, very clear, this is not fractional part of x, don't be confused. Now since you have learned fractional part of x, when you see a bracket you will think, oh, this is fractional part of x. Whenever in question it is given, it will be mentioned where this is fractional part of x, but here it is not given, so this is an ordinary bracket. Yeah, or it will be given this bracket, so this is greatest integer function. So it is not given, it means it is not. Yeah, guys, you must now keep all these into mind since now you are in class 11, 12, and this is very important for you all. So can I write this? Right. So half, can I write this as, can I write this 2fx as fx plus f of minus x, fx plus f of minus x plus fx minus f of minus x. So fx plus fx is 2fx, and f of minus x cancel f of minus x, right? So I can write this, now I can write this as f of x plus f of minus x by 2, can I write this? Yeah, plus f of x. So fx and this part I have taken, f of x minus f of minus x upon 2. I can write this like this. Say for example, this is gx and this is hx. Clear to you all? This is gx and this is hx, right? So basically I have written fx is equal to gx plus hx I have got, where gx the value is, f of x plus f of minus x by 2, right guys? Now let us see what kind of function this is. So if I find g of minus x, guys, if I write g of minus x, so this becomes f of minus x and this becomes f of x by 2, which is nothing but gx. So g of minus x is equal to gx, guys. G of minus x is equal to gx, hence gx is even. Now let us examine what is hx. So hx is f of x minus f of minus x upon 2. If I find h of minus x, so this becomes f of minus x minus f of x upon 2. Guys, this is nothing but minus h of minus x. So h of minus x is equal to what? Minus h of minus x. This is, I hope this is very clear to you all, because this fx come in front and this minus, so minus comes in front and this becomes minus sign, minus h of minus x. So hx is odd. Done, guys. Fx is a sum of gx plus hx. One is even, one is odd. So any function, guys, you can write it in the form of a sum of even and a sum of odd function. This proof itself is important, and knowing this fact is also important. I think this was very useful. This will be very useful to you all when you solve different problems, solving problems. Guys, let me tell you one thing. Once I have taught you concept over here, once you have seen this video, you have solved the numerical on your own. As we proceed in this video, you must always go back. You must take up a standard textbook of joint entrance examination, or your basic class 11, 12, you can take up any book. You can take up R.S. Agarwal, you can take up R.D. Sharma. You need to solve those problems first. You need to study the theory and you need to solve the entire exercise. And then you can take up any JEE main advanced textbook that are available in the market. I'm not recommending right now. Yeah, and then you can go back and solve previous year examination questions. I'll also build up a series wherein I will be solving the questions that have come in previous year joint mains examination. You need to solve this question to understand actually what is asked. In the examination. So guys, let us solve the next question. So in this question it is given if fx is even function, if fx is even function defined on minus 5 comma 5. You can note in the question as I read, if fx is even function defined on minus 5 comma 5, which means this graph is restricted between minus 5 and 5, then find 4 real values of x. You need to find 4 real values of x. You need to find 4 real values of x for the equation f of x is equal to f of x plus 1 by x plus 2. So the question is this, yeah. So it is given that fx is even function and defined in between minus 5 and 5. You need to find 4 real values of x. So this question is very simple. What you need to do over here, simply if this is equal to this, then this interior part should be equal to this interior part. So the first part is very simple, x is equal to x plus 1 by x plus 2. This part multiplied, x square plus 2x. This part comes this side, minus x minus 1 is equal to 0, guys. So basically x square plus x minus 1 is equal to 0. How do we solve this equation? In the quadratic equation series, we have already seen how we can solve quadratic equations by applying Siddharacharya formula. So x square plus x minus 1, you will get x is equal to, I am just writing down the formula for those who don't remember. So ax square plus bx plus c is equal to 0. The solution of this equation is x is equal to minus b plus minus root over discriminant b square minus 4ac by 2a. So I am applying this formula and getting the values of x. So my agenda is not to teach this part here. So the value of x here will be minus 1 plus minus root 5 upon 2 into 1, 2. So this is the value of x. So these are the two values of x. So minus 1 minus root 5 upon 2 and minus 1 plus root 5 upon 2. So you got already two values of x from this. Now it has been said, so you have got two values, but in the question it is asking 4 real values. So how can you get 2 more values? Now guys, understand, it is said that fx is even. So f of minus x will be equal to what? Fx. F of minus x will be equal to fx. So basically guys, f of minus x will be equal to fx, which means this still holds true. F of x is equal to f of minus x, guys. Very clear? So basically what happens? So what happens this side? One answer you have already got. What happens, guys? So you can write what? Minus x is equal to x plus 1 upon x plus 2. Solving it, minus x square minus 2x is equal to x plus 1. Let's take this side. So x square plus 3x plus 1 is equal to 0. X square plus 3x plus 1 is equal to 0. Here you get the value of x is equal to minus b plus minus root over b square minus 4ac, that is root 5 upon 2 into 1, 2. This is the value of x that you get. Simple even function. So f of minus x is equal to what? Fx. So you are equating minus x with x plus 1 by x plus 2, and this is the two value that you got. So what is the final answer? What are the 4 values? So the 4 values are, I am writing it, x, the 4 values of x, real values of x are minus 1 plus root 5 upon 2, minus 1 minus root 5 upon 2 you got previously, and here you are getting minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. I think, or plus minus, whatever you write it in this form, minus 1 plus minus root 5 by 2 you got earlier. So I am just breaking it, minus 1 plus root 5 by 2, minus 1 minus root 5 by 2, and minus 3 plus root 5 by 2 here, and minus is there, so minus 3 minus root 5 by 2. These are the 4 real values of x that you get. So this was one of the conceptual problems that you got. Now let me tell you another important concept over here in odd and even function before I close this chapter. So one important factor that you need to remember is that the derivative of an odd function, that the derivative means differentiation actually, derivative of odd is even, and the derivative of even function is odd. If somebody knows derivative, let me teach a little bit here, but if you don't know, you must first see the differentiation chapter that I will be teaching in this series. So basically, if y is equal to fx is equal to x square, so what is the differentiation of this, guys? Dy upon dx is equal to what? 2x. 2 comes in between, in front, and then x minus 1. So basically the formula is, if fx is equal to x to the power of n, the formula of differentiation, that is dy upon dx, or in this case f dash x is also written. So this is n comes in front, x to the power of n minus 1. So 2 comes in front, x to the power of 2 minus 1. So this is 2x. So differentiation, you can see this is even function, and guys, y is this function 2x is odd. So differentiation of even function is odd function. If the function would have been y is equal to fx is equal to x cube, this is what? This is odd function. Here dy by dx, the differentiation of the function, or f dash x, will be 3. This formula I am applying, 3 into x square. 3x square, guys, x square is there. This will be what function? This will be even function. This will be even function. So you saw that the derivative of an odd function, is an even function, and the derivative of an even function, the derivative of this function, is an odd function. This is very important. You need to understand this. Another concept with which I will be ending this chapter is that you need to understand that when a function which is either odd or even, when squared, will always become even. Yeah. So say for example, a function is given. So we already saw the derivative part. If you have not seen differentiation, we will be coming a series, we will understanding how to differentiate function. We will be more seeing into the formulas. So basically differentiation formula is, if y is equal to fx is equal to x to the power of n, you need to remember this formula, dy by dx is n x to the power of n minus 1. Yeah, this is differentiation formula. We will be seeing this in differentiation chapter. I wrote it down. But what I was saying is, say for example, y is equal to fx is given. If you square the function, say for example, this is odd function. Say for example, this is odd. If you square the function, guys, so fx whole square, the function that will form will be even. If a function is even, if you square the function will still be even. So the point over here is, if a function which is either odd or even, when squared becomes even. So a function either odd or even, when squared means whole square. Yeah, when squared becomes what? Becomes even. Guys, remember this. So guys, I am ending the chapter on odd and even function on this note. I think all the concepts related to odd and even are clear to you. If you have doubt, you can go to the comment section and write your doubts. Solve some numericals, previous year questions, and take some complex problems from some advanced book of JEE Main and Advanced. And if you like the video, do subscribe to our channel. Thank you for watching.